This video introduces a prototype called as Maya. Maya stands for Multimodal Automated Interpretability Agent. This Maya combines a pre-trained vision language model backbone with an API containing tools designed for conducting experiments on deep networks. Maya is prompted with an explanation task, for example, describe the behavior of unit 487 in layer 4 of CLIP, or in which context does the model fail to classify any sort of animal. And then Maya designs an interpretability experiment that composes experimental modules to answer the query. Maya's modular design enables flexible evaluation of arbitrary system, as you can see in this diagram. Maya's modular design is a very unique design because it enables this flexible evaluation of these systems and straightforward incorporation of new experimental tools. You can also check out the current tooling in Maya's API, including modules for synthesizing and editing novel test images, which enable direct hypothesis testing during the interpretation process. Understanding of a neural model can take many forms. Given an image classifier, for example, we may wish to recognize when and how it relies on sensitive features like race or gender, identify systematic errors in its prediction, or learn how to modify the training data and model architecture to improve accuracy and robustness. These days, these kind of understanding requires significant effort on the part of researchers involving exploratory data analysis, formulation of hypotheses, and controlled experimentation. As a consequence, this kind of understanding is slow and expensive to obtain even about the most widely used models. That is where this research comes very handy. And also, there is other research going on automated interpretability that has begun to address some of these limitations by using learned models themselves to assist with model understanding tasks, for example, by assigning natural language descriptions to learned representation, which may then be used to surface features of concerns, as you can see in this example. But current methods are still only useful as tools for hypothesis generation. They characterize model behavior on a limited set of inputs and are often low precision. So this paper addresses as how can we build tools that help users understand models while combining the flexibility of human experimentation with the scalability of automated techniques. So in this diagram, what is happening is you can see the Maya's interpretation of features in the wild. Maya iteratively writes programs that compose pre-trained modules to conduct experiments on subcomponents of other systems. Generated code is executed with a Python interpreter and the outputs. And you can see that the neuron activation values overlaid in white masks thresholded at 0.95 percentile of activations. And then these are returned to Maya. Equipped with an API containing common interpretability tools, Maya autonomously designs experiments that show sophisticated scientific reasoning. There are a lot of other good things happening in this paper. For example, if you look at this diagram, Maya can be used to automatically surface model level biases. Specifically, they have applied Maya to investigate biases in the outputs of a CNN and in specific ResNet 152 trained on a supervised ImageNet classification task. The Maya system is easily adaptable to this experiment. The output logic corresponding to a specific class is instrumented using the system class and returns class probability for input images. Maya is provided with a class label and instructed to find settings in which the classifier ranks images related to that class with relatively lower probability values or shows a clear preference for a subset of the class. So this diagram presents results for a subset of ImageNet classes. This simple paradigm suggests that Maya's generation of synthetic data could be widely useful for identifying regions of the input distribution where a model shows poor performance. While this exploratory experiment surfaces only broad failure categories, Maya enables other experiments targeted at end use cases identifying specific biases. So, all in all, if you look at the high level, Maya is an agent that automatically automates interpretability tasks, including feature interpretation and bias discovery, by composing pre-trained modules to conduct experiments on other systems. While human supervision is needed to maximize its effectiveness and catch common mistakes, initial experiments with Maya show promise, and these researchers are anticipating that interpretability agents will be increasingly useful as they grow in sophistication. I hope that you enjoyed this new project. I will drop the link to its paper in the video's description. Go through it, let me know what do you think. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.